There is a direction in the sky, toward the constellation Boötes, where the galaxies thin out and then for a stretch of about 330 million light-years, almost stop. Not a few fewer galaxies, a region so empty that if you put it where our own neighborhood is and counted what ought to be inside it, you would expect around 2,000 galaxies, and instead you would find roughly 60. It is one of the largest empty regions we have mapped, and when it was first found, the obvious thought was that something had gone wrong, that galaxies had been destroyed or pulled away or hidden, that a hole this size in an otherwise crowded universe had to be a wound. But nothing went wrong there. Nothing was taken. The emptiness is not a wound, and it is not rare, and that is the part that should unsettle you. The Boötes void is not the strangest place in the universe. It is one of the most ordinary, and the crowded sky we live under is the exception. So the real question is not what emptied it, it is why we ever thought full was normal. Tonight we are going to walk into the Boötes void and work out what it actually is, why it is so empty, and why it becomes far more frightening once you understand that nothing is wrong with it. By the end of this you will understand how a region that size empties itself, why most of the universe is built out of regions exactly like it, and why the bright, crowded sky we take for granted is a thin and temporary exception that is already starting to come apart. I am not going to dress this up. The terror of the void was never that it is a mystery, it is that it is the rule. We are the exception, and the exception does not last. If you like standing in the strange, empty places out here with me, a quick like or subscribe helps these videos find the other people who would too. Now, let us begin. Start with the number, because the number is the whole problem. There is a region of space out toward the constellation, and measured from one side to the other it runs about 330 million light-years. Inside a volume that size, filled at the rate the rest of the universe is filled, you would expect to find something on the order of 2,000 galaxies. The real count is around 60, 2,000 expected, 60 found. That one fact is the seed the whole of tonight grows out of, and the more carefully you look at it, the worse it gets. Let me give you the size in a form you can hold, because 330 million light-years is a phrase that slides off the mind. A beam of light, the fastest thing there is, crosses from the Earth to the Moon in a little over a second. It crosses our entire galaxy, edge to edge, in about 100,000 years. To cross the Boötes void, that same beam needs 330 million years. That is not a number from human experience. The last time Earth was 330 million years younger than it is now, there were no dinosaurs yet. The first reptiles were a recent development, and the land had only just been colonized by anything with a backbone. A beam of light setting out across the void back then would be arriving at the far side right about now, and for almost that entire crossing, there would be nothing beside it. No star, no galaxy, nothing to light and nothing to pass. That is the part that is hard to take in. We are not talking about a region that is a little underpopulated, a quiet suburb of the universe. The Boötes void is roughly 60 to 80% below the average density of matter in the universe. Most of what should be there simply is not. And the galaxies that are there are scattered so thinly across that enormous volume that they are isolated in a way nothing in our own sky is. Out here, on our bright thread, our galaxy has a close companion. Andromeda sits about 2.5 million light-years away, near enough that the two of us are bound together by gravity and falling slowly toward each other. For a galaxy sitting deep in the Boötes void, the nearest large neighbour is not 2.5 million light-years off. It is tens of millions of light-years off, 10 or 20 times farther, far enough that from the surface of any world in that galaxy, the other galaxy would be a faint smudge at best, and very possibly nothing the eye could catch at all. The first galaxy anyone found inside the void makes the point on its own. It was a single spiral, turning by itself, with no close company in any direction. People who study these things took to calling it the loneliest galaxy, and the name is earned. A spiral galaxy is 100 billion stars or more. a whole disk of suns and the worlds that go with them. And this one is sitting in the middle of an emptiness so wide that its nearest large neighbour is tens of millions of light years away across the dark. Whatever is on those worlds, if anything is, came up under a sky that is its own stars and then almost nothing. We will come back to that sky because it turns out to matter more than anything else tonight. Put the deficit as a fraction and it is even starker. 2,000 expected, 60 found, means that something like 97 of every 100 galaxies that ought to be in that region are simply not there. Not dimmed, not hidden, not hard to see, not there. If you took our own crowded neighbourhood and removed 97 of every 100 galaxies in it, you would have something like the Boötes void, a few survivors scattered across an emptiness where a full population used to be implied. That is the scale of the absence. It is not a region that came up a little short. It is a region that is missing almost everything it should have, holding on to a small remnant and nothing more, across a span 330 million light years wide. Now the void does have edges, and the edges are the tell. The Boötes void is not floating alone, it is bordered by some of the densest structures in this part of the universe, the Hercules supercluster, the Corona Borealis supercluster, the Boötes supercluster. Great bright walls of galaxies packed close, so you have this enormous near-empty region, and around its rim, the matter is piled high. Hold on to that, because it is the first quiet clue that the emptiness was not random and was not violent. The galaxies that are missing from the middle did not vanish. They are sitting in the walls. We will follow that clue in a few minutes, because it is most of the answer to how a place like this comes to exist. The void was first mapped a little over 40 years ago, picked out from the pattern of galaxies at a certain distance in that direction, a gap in the count that was too large and too clean to be an accident of where anyone happened to be looking. Since then, the count of galaxies inside it has crept up, from a literal handful to a few dozen, as deeper surveys found the faint stragglers that were there all along. But the picture has not softened, every deeper look has confirmed the basic thing. This is a real region, hundreds of millions of light years across, and it is close to empty. I want to be honest about what we do not know, because it matters, and because this channel does not paper over it. The exact edges of the Boötes void are fuzzy. Voids do not have walls you could stand at, a clean line where the emptiness stops and the full universe starts. They fade. The density climbs gradually from the bare middle out toward the crowded rim, so where you draw the boundary is partly a choice. There is also a real question about whether the Boötes void is one void or several. The galaxies that are inside it are not scattered at random. They seem to trace a kind of structure running through the middle, which is the sort of thing you would expect if what we call the Boötes void is actually 2 or 3 smaller voids that have grown into one another and merged, with the remains of their old dividing walls still strung across the inside. We do not have that fully pinned down. What is not in any doubt is the headline. Whatever its exact shape and however it came together, this is one of the largest and emptiest regions we have ever found within reach of our surveys. It is worth saying how a thing like this even gets noticed, because the way it was found tells you how real it is. You do not see a void directly. There is nothing to see. You find it by counting galaxies at different distances in a given direction, and noticing that at one particular range, in that patch of sky, the count falls almost to nothing and stays there across an enormous span before the galaxies pick up again on the far side. The first time that gap turned up toward Boötes, it would have been easy to write off as a quirk of where the survey happened to look. But the gap showed up the same way along separate lines of sight, through that region, 3 different directions all going quiet at the same distance, and a gap that clean and that consistent is not an accident of sampling. It is a hole in the actual distribution of matter. The galaxies are not there because there are no galaxies there to count. Let me give you the scale one more way, because it is the thing that keeps escaping the mind. Our entire galaxy, the Milky Way, with its few 100 billion stars, is about 100,000 light years across. The Boötes void is about 330 million light years across. That means you could line up our whole galaxy, edge to edge, more than 3,000 times across the width of the void, and the void would still have room. And across that entire span, 3,000 galaxy widths of it, there are about 60 galaxies total. Spread 60 galaxies through a volume that size, and you can work out roughly how far apart they sit. And the answer is that each one is on its own in a region tens of millions of light years across, with the nearest other galaxy the whole width of that gulf away. These are not neighbours who happen to live far apart. These are galaxies for which the concept of a neighbour barely applies. And every one of those 60 is the exception, not the rule, inside the void. The rule inside the void is nothing. If you picked a point at random inside the Boötes void and looked around, the overwhelmingly likely thing is that you would find yourself in a region with no galaxy near you at all, the closest one tens of millions of light years off in some direction, and the rest of the void stretching out empty in every direction past it. The 60 galaxies are not what the void is. They are the few stragglers that the draining left behind. What the void is the space between them, and the space between them is almost all of it. Look at what borders it, because the walls around the Boötes void are as telling as the emptiness inside. This is not a region tucked away in a quiet, average part of the universe. It is fenced by some of the densest structure anywhere near us. On its edges sit the Hercules supercluster and the Corona Borealis supercluster, great concentrations of galaxies, part of a band of structure so large it ranks among the biggest things in the known universe. So the arrangement is not a gentle dip surrounded by ordinary space. It is the emptiest large region nearby, ringed by some of the fullest. The extremes sit side by side, the most crowded structures wrapped around the most barren one, and that pairing is not a coincidence, as we will see in a few minutes. It is the signature of how the void was made. For now, just hold the contrast. The deepest nearby emptiness is fenced by the densest nearby crowds, and the two are touching. And there is one more thing to sit with before we ask what emptied it, because it reframes the whole place. Put our own galaxy at the centre of the Boötes void, in place of that lonely spiral, and ask what our sky would look like. It would look almost bare, our own band of stars overhead, and then, in every direction, an emptiness with the nearest other galaxy tens of millions of light years off, far too faint to catch by eye. We learnt that the universe is full of galaxies almost the moment we built instruments capable of finding them, because in our real position the nearest ones are close and bright and impossible to miss. From the centre of the Boötes void, that discovery would have been brutally hard. We might have looked up for a very long time and concluded that our galaxy was most of what existed, an island with a few faint smudges at the edge of detection, and otherwise nothing. The same minds, the same instruments, the same care, in that location, would have built a picture of a small and lonely universe, and had no easy way to learn better. Where you stand decides what you can know, and almost nowhere in the universe is a place that lets you know as much as our actual address does. Hold that too, because it is the thing the whole second half of tonight turns on. So that is the void, stated plainly for what it is. Not a thing, an absence, the largest nearby example of nothing, 330 million light years of almost pure emptiness, 60 galaxies where there should be 2,000, the few that are there marooned tens of millions of light years from the nearest company, and a rim of bright, crowded walls fencing it in. And the natural response to all of that, the response everyone has, is the response that named this video. A hole that big in a crowded universe looks like damage. It looks like something happened. So that is the question we go to first, and it is the obvious one. Something must have emptied it. Something must have reached in and taken the galaxies out, or destroyed them, or driven them off. So what was it? The answer is that nothing happened. Nothing reached in. Nothing was destroyed. Nothing was driven off. Nothing was taken. The Boötes void was not emptied by an event at all. It emptied itself slowly over billions of years by the most ordinary process in the universe. And once you see how, the word mystery starts to feel like the wrong word for it. The honest description is not a crime scene. It is a slow draining that was written into that patch of space from almost the very beginning. Go back to the early universe, not long after the beginning, and the matter that would become every galaxy was spread out almost perfectly smoothly. Almost, not quite. There were differences from place to place, but they were tiny, apart in 100,000, the faint unevenness left over from the first instance. Some regions started with very slightly more matter than average. Some started with very slightly less. That is the whole of it. That is the seed. Those differences were so small that if you had been there to look, you would have called the early universe uniform and moved on. But they were not zero, and gravity does not need much to work with. Here is what gravity does with a head start that small given enough time. A region that begins with a little more matter than average pulls a little harder on everything around it. So it draws in more matter, which makes it denser, which makes it pull harder still, which draws in more. A region that begins slightly dense becomes the place where matter collects, and over hundreds of millions and then billions of years it grows into a knot, a cluster, a wall of galaxies. And the matter it pulls in has to come from somewhere. It comes from the regions next door that started with slightly less. Those regions, already a little thin, give up their matter to the growing dense ones around them, and so they become thinner, which means they pull even more weakly, which means they hold on to even less. A region that begins slightly empty becomes the place that matter drains away from, and over the same billions of years it grows into a void. That is the entire mechanism. The rich regions get richer, and the poor regions get poorer, written across the whole universe at once, on a scale of hundreds of millions of light years. The matter does not disappear from a void, it migrates. The galaxies that should have been in the middle of the Boötes void formed at the edges instead, or drifted outward over time toward the growing walls, pulled by the rising density of the surroundings. This is why the void is fenced by those bright superclusters, the Hercules, the Corona Borealis, the Boötes walls. That is not a coincidence, and it is not a frame around the emptiness. Those walls are where the missing galaxies went. The matter that is not in the void is piled up exactly around its rim, because the rim is what drained it. The void and its walls are two halves of one process. You cannot make the walls without emptying the middle, and the middle emptied to build the walls. There is something worth pausing on in how small that starting unevenness was. 1 part in 100,000 is an almost perfect smoothness. The early universe was very nearly uniform. The matter spread out so evenly that the differences from place to place were a rounding error, a faint texture you would have to measure carefully to detect at all. And yet that faint texture was the entire blueprint. Every galaxy, every cluster, every wall, and every void, including the Boötes void, grew from those tiny initial differences, amplified by gravity over billions of years, until a 1 part in 100,000 ripple became the difference between a crowded supercluster and a near total emptiness, 330 million light-years across. The whole structure of the universe, the full places and the empty ones, was latent in that nearly smooth beginning, waiting for gravity to develop it. The Boötes void was not added later. It was there at the start, as a slightly thin patch in an almost uniform haze, and everything that sets it apart now is just that original faint thinness, carried to its conclusion by time. Nothing was needed to make the emptiness, except a tiny head start and a great deal of patience, and the universe had both. And it is gentle. That is the part that surprises people. There is no violence in it anywhere. No explosion cleared the Boötes void. Nothing was blasted out. If you had been standing somewhere inside that region while it emptied, across the hundreds of millions of years it took, you would have noticed nothing happening at all. The galaxies near you would have drifted apart so slowly, that across a million years the change would be too small to see. The draining of a void is not an event you could witness. It is a direction, a tendency, a steady leaking of matter from the thin places to the thick ones, running quietly under a sky that looked still the whole time. The Boötes void did not die. It was never alive. It simply started with slightly less than its neighbours, and slightly less was enough, because gravity always takes from the poor and gives to the rich, and it has had almost the entire age of the universe to do it. I find that more unsettling than any explosion would be, and I want to be clear about why, because it is going to come back at the end. If the void had been carved out by some catastrophe, it would at least be a special place, a scar, an exception, the site of something that went wrong. It is not. It is the ordinary outcome of ordinary physics running for a long time. There is nothing exceptional about it except its size. It is what a slightly empty patch of the early universe turns into if you leave it alone, and the early universe was full of slightly empty patches. Keep that in your mind, because the moment you accept that the void is normal rather than damaged, the floor starts to tilt, and the rest of tonight is the floor tilting. Now, the honest admission, because there is a real one here. The mechanism, the draining of underdense regions and the growth of voids is settled. We see it in the surveys, we see it in the way galaxies are arranged, and it falls straight out of the physics with no special pleading. What is not fully settled is the detailed biography of this particular void. As I mentioned, the galaxies inside the Boötes void are not scattered evenly. They seem to trace a structure across the middle, and the most natural reading of that is that the Boötes void is not one void, but the merger of 2 or 3 smaller ones, each of which drained on its own, the dividing walls between them thinning and dissolving until the separate emptinesses became a single great emptiness, with the ghosts of the old walls still threaded through it. That reading is likely but not certain. We are reconstructing a history that took billions of years from a single snapshot, the one we can see now, and a single snapshot can only tell you so much about how a thing came to be. So the exact story of how the Boötes void assembled itself is open. The fact that it assembled itself by ordinary draining and not by any event is not. And we are not guessing about that faint early unevenness. We can still read it, the oldest light in the universe, the glow left over from when everything was hot and dense, fills the whole sky, and printed across it are the slightly warmer and slightly cooler patches that mark where matter was very slightly bunched and very slightly thin at the start. The difference between the dense spots and the thin spots is about 1 part in 100,000. That is the seed catalogue, the original map of where every wall and every void would eventually grow. The thin spots in that ancient light are the voids of today, caught at the very beginning, before gravity had done anything with them. The Boötes void is one of those original thin spots grown up. It was always going to empty. The instruction was written into that patch of space when the universe was a few 100,000 years old, and the universe has been carrying it out ever since. That is the thing to hold about the timescale. The draining of the Boötes void was not quick, and it was not an event with a date. It ran for most of the age of the universe, billions of years of matter leaking from the thin middle to the thickening walls so slow that across any stretch of time a living thing could perceive, nothing was happening at all. If you had stood inside the void at any point during the billions of years it took to empty, you would have seen a normal sky and a normal scatter of galaxies around you, drifting apart so gradually that across a million years the change would be too small to notice. There was never a moment when the void emptied. There was only a direction, held for an immense span, the steady migration of matter from where there was less to where there was more. And the same process that emptied the Boötes void built everything else in the universe at the same time. This is the part one think is genuinely worth sitting with. The universe started nearly uniform. Matter spread almost perfectly smoothly with only that 1 part in 100,000 of unevenness, and then gravity sorted it. Everywhere there was slightly more, it pulled in more and grew into a galaxy, a cluster, a wall. Everywhere there was slightly less, it gave up what it had and grew into a void. The same single process, running everywhere at once for billions of years, produced both the bright places and the dark ones, because they are two outcomes of one sorting. The walls exist because the voids drained to build them. The voids exist because the walls pulled the matter out of them. You cannot have one without the other. The crowded sky we live under and the empty void in Boötes are not opposites that happen to sit near each other. They are the two halves of the same act, the sorting of a nearly uniform universe into the full and the empty, and the sorting is still going on. And there is a deeper layer to the draining that is worth naming because it is what actually does the work. The galaxies we count are not the main thing moving. They are markers, bright tracers riding on top of a much larger amount of matter we cannot see directly. The dark matter that makes up most of the mass in the universe and provides the real scaffolding the galaxies hang on. When a region drains, it is the dark matter that drains, the whole mass of the region migrating toward the denser surroundings, and the galaxies go along because they sit in it. So the Boötes void is not just a place that is short on galaxies, it is a place that is short on mass, total, seen and unseen. The dark matter drained out of it, along with everything else, into the same walls, leaving the middle not just dim but genuinely light, a real deficit of substance and not merely a gap in the bright tracers. When I say the void is empty, I mean it at the level of mass itself, not just at the level of the galaxies we happen to be able to see. The thing that is missing is most of the matter that should be there, and most of that matter was never the kind that shines. And there is a turn in that which is worth taking before we move on, because it implicates us directly. The same sorting that emptied the Boötes void is the reason anything like us exists at all. Life needs a galaxy, and a galaxy needs a place where matter collected rather than drained, a thread or a wall or a knot where gravity won and pulled material together into stars and worlds. Those places exist only because other places emptied to feed them. We are on a thread. We are made of matter that collected in a region that won the sorting, and the price of our region winning was that other regions lost, drained, emptied, became voids. The Boötes void and a galaxy like ours are not just two outcomes of one process in the abstract. They are bound together. The emptiness over there is part of why the fullness over here exists. The matter that left the void helped build the kind of dense structure that galaxies and stars and worlds and we require. We owe our existence to the same draining that we find so unsettling when we look at where it ran to completion. The void is not only our future, as we will see, it is in a sense the cost of our past. So we can put the first fear to rest. Nothing emptied the Boötes void. It is not a wound and there is no culprit. It drained, the way a thin place always drains, into the walls around it, over a span of time that makes the entire history of life on Earth look brief. But that answer does not make the void less frightening. It makes it more frightening, and here is the turn that does it. If the Boötes void is just the ordinary result of ordinary physics, if all it took was a patch of space that started slightly emptier than average, then there is no reason for it to be the only one. The early universe had thin patches everywhere, so the question changes, and it gets bigger. It stops being a question about one strange region in Boötes and becomes a question about the whole universe. If a void is just what a thin patch becomes, then how much of the universe is voids? Is the Boötes void a freak that we happened to find, or did we find it because places like it are everywhere, and this one was simply close enough and large enough to catch our eye first? Here is the answer, and it is the one that changes the shape of the whole night. The Boötes void is not a freak. It is not rare. It is one example, the nearest large one, of the single most common kind of place in the universe. Most of the universe is voids. Not most of the galaxies, most of the volume. The great majority of all the space there is, taken by sheer size, is empty regions like the one in Boötes, and the bright crowded places, the walls and clusters and threads where the galaxies live, are the thin exception wrapped around all that emptiness. We have the picture backwards. We think of the universe as galaxies, with some gaps in between. It is closer to the truth to say the universe is gaps, with a little lacing of galaxies strung through them. When the surveys map where galaxies actually sit, across hundreds of millions of light years, what comes back is not a scatter and it is not a crowd, it is a structure. The galaxies collect along enormous thin sheets and narrow threads. Where the threads cross, you get dense knots, the clusters and superclusters, and the sheets and threads wrap around enormous rounded hollows, the voids, which take up the space in between. The whole arrangement has a name, the cosmic web, and the word web is doing honest work, because that is what it looks like, matter pulled out into filaments and sheets, with great empty cells between them. The bright material is all in the strands, the cells are the voids, and the cells are most of the volume. How much is most? The exact figure depends on where you decide a void ends and a wall begins, which, as we said, is partly a choice, because the density fades rather than stops. But by any reasonable accounting, voids take up the large majority of the volume of the universe, well over half, and by some measures a great deal more than half. Roughly half of all the space there is began on the underdense side of that early ledger, slightly thinner than average, and all of those thin regions have spent the age of the universe doing what the Boötes void did, draining toward their walls and growing emptier. A typical void today holds less than 1/10 of the average density of matter. Most of the universe, measured by where you could actually be, is closer to empty than to full. So sit with what that means about the Boötes void specifically. It is not special in kind, it is special only in size and in nearness. It is large, and it is close enough that we could map it clearly, which is why it has a name and a reputation. But there are voids in every direction. The sky is full of them. They are the ordinary background condition of the universe, the thing space mostly is. The Boötes void got famous because it was one of the first really large ones we pinned down, and because its emptiness is so close to total. It did not get famous because it is unusual. It is the opposite of unusual. It is the rule, caught early and at close range, before we understood that it was the rule. This is the inversion the whole video turns on, so let me state it as plainly as I can. The crowded sky you see on a clear night, the band of the Milky Way, the few thousand stars, the smudge of Andromeda if you know where to look. All of that is not the normal state of the universe. It is a rare and local condition. You happen to live inside one of the bright strands of the cosmic web, on a thread where the matter collected instead of draining, and so your sky is full. Move off the thread, out into one of the cells, and the sky empties. And the cells are most of the universe. The fullness you were born into and assumed was simply how things are, is the exception. The emptiness is the body of the thing. We are the unusual case, standing in one of the few lit strands, mistaking our strand for the whole. The honest admission here is the one I already flagged, and it is small. The precise fraction of the universe that counts as void is not a single agreed number, because it depends on definitions, on how empty a region has to be before you call it a void, rather than just a thin patch of the web. Different surveys and different methods give somewhat different fractions, but that is an argument about exactly how much of the universe is empty, not about whether most of it is. That most of the volume is void is not in dispute. The disagreement is only over whether it is a large majority or an overwhelming one. And there is a second thing worth saying plainly, because it is easy to lose. When I say the universe is mostly empty, I do not only mean the obvious emptiness of space, the gaps between stars inside a galaxy, the long reaches between one star and the next. That kind of emptiness is real too, but it is not what tonight is about. I am talking about a higher level of emptiness, the emptiness between the strands of the web, regions hundreds of millions of light years across, where there are barely any galaxies at all, not just barely any stars. Whole volumes the size of the Boötes void, scattered through the universe beyond counting, each one a near total absence of the bright structure we think of as the universe. That is the scale of emptiness that is the rule, not the dark between the stars, the dark between the galaxies. in regions so large that a galaxy is a rare thing to find inside one. We know this because we have mapped it. Survey the sky carefully, measure the distance to galaxy after galaxy until you have millions of them placed in 3 dimensions, and the shape that emerges is unmistakable, and it is the same everywhere you look. The galaxies are not spread through space. They are pulled out into long, thin filaments and flat, broad sheets, meeting at dense knots and wrapped around great, rounded, empty cells. Slice the map any way you like and you see the same thing, bright threads and walls enclosing dark hollows over and over, to the limits of the survey. It is not a scatter with some gaps, it is a definite structure, and the structure is mostly holes. There is something worth noticing about the shape of it. The matter in the universe has collected onto sheets and threads, which is to say it has collected onto things that are thin. A sheet is wide but it has almost no thickness. A filament is long but it has almost no width. The bright structure of the universe is built out of these thin things, and thin things take up almost no volume no matter how wide or long they are. The emptiness, by contrast, is the 3-dimensional space between them, the full-bodied interior of every cell, and that is where nearly all the volume is. So the arrangement is one where the matter lives on the boundaries, and the emptiness fills the space they enclose. The galaxies are the sheets and the threads and the edges. The voids are the space those sheets enclose, and a region is mostly its interior, not its boundary. This is why the count comes out the way it does. We name the bright things, the galaxies and groups and clusters and superclusters, and we treat the dark between them as the gaps, the background, the nothing in particular that the real things sit against. But by volume it is exactly the other way round. The voids are the body of the universe and the bright web is the boundary drawn through them. If you wanted to describe the universe honestly by what most of it is, you would not describe galaxies and mention the gaps. You would describe the emptiness and mention that it has a faint, bright skin stretched over its divisions. The Boötes void is not a hole in the universe, it is a piece of the main substance of the universe, and our bright, crowded neighbourhood is a piece of the rare skin. Here is the volume point, made as plain as I can make it. Pick a straight line across the universe, any direction, and follow it for a few billion light years. Most of that line, the large majority of its length, runs through the insides of voids, through emptiness, with nothing nearby on either side. Every so often the line crosses a wall or a thread, and for a relatively short stretch there are galaxies around it, the bright structure, the crowded part. Then it passes out the other side and back into emptiness for another long run. The trip is mostly void with occasional brief crossings of structure, not mostly structure with occasional gaps. If you measured how much of the line spent its length in the full places versus the empty ones would win easily. That is what it means for the universe to be mostly void by volume. It is not an abstract bookkeeping claim. It is the plain fact that if you went in a straight line across the universe, you would spend most of the trip in the dark, in regions like the Boötes void, and only now and then pass briefly through somewhere like here. I should be honest that even a void is not perfectly empty, because precision matters and the channel does not round off in the scary direction for effect. There are the stragglers, the 60 galaxies in Boötes, and their equivalents in other voids. There is a thin haze of matter that never fully drained. A void is not a perfect vacuum scrubbed down to absolute nothing, but it does not need to be, for the point to stand. A region with less than 1/10 of the average density of matter, hundreds of millions of light years across, with a handful of marooned galaxies and otherwise almost nothing, is empty by any standard that means anything, and that kind of region is most of the universe by volume. The emptiness does not have to be flawless to be the rule. It only has to be this thorough, and it is. And the Boötes void is not even the largest emptiness there is. It is famous because it is large and close and clean, one of the first big ones we mapped well. But the universe holds voids of every size, from modest ones tens of millions of light years across, up to enormous underdense regions far larger than Boötes. There are stretches of the universe where the underdensity runs across 1 billion light years or more. regions so large that the Boötes void would be a single cell within them. The Boötes void earned its name not by being the emptiest or the biggest, but by being a clear, close, well-defined example at a time when the scale of cosmic emptiness was still sinking in. It is the one people learnt to point to, but it is one of an uncountable number in every direction, of every size, and far from the most extreme. The emptiness does not come in one famous size. It comes in all sizes everywhere, and the famous one is simply the one that happened to be near enough to study and large enough to notice early. And this arrangement was not what anyone expected to find. For a long time, the natural assumption was that the universe, on the largest scale, would be smooth. Galaxies sprinkled more or less evenly through space, thinning out into a uniform scatter once you looked across distances large enough. The expectation was something even and featureless if you stood back far enough. What the maps actually showed, once we could measure distances to enough galaxies to see the large-scale shape, was the opposite of that smoothness. It was structure, sharp and intricate and everywhere. Sheets and threads and great empty cells, all boundaries and hollows rather than an even spread. The emptiness was not a thinning at the edges of a uniform scatter. It was a defining feature, carved into the universe at every scale we could reach, with the bright matter pressed onto the boundaries of enormous dark cells. The universe is not an even scatter of galaxies with some gaps in it. It is all structure and hollows, the bright matter pressed onto thin boundaries and the emptiness filling the cells those boundaries enclose, and the cells are most of it. So the void has gone, in the space of a few minutes, from a strange hole to the ordinary condition of almost everywhere. It drained itself by plain physics, and the plain physics ran everywhere, so the universe is mostly the result. The dark we started with as one region in Boötes is now the body of the universe, and the bright places, including ours, are the thin exception laced through it. Which forces the next question, and it is not an abstract one. If most of the universe is empty in this way, if most of the space there is to exist in is deep inside one of these cells, then most of the places you could possibly be are not places like this. They are places like the middle of the Boötes void. So what is it actually like out there? What would the universe look like? What would it be from inside the emptiness that is most of everything? That is where we go next, and it is where this stops being a fact about distant regions and starts being something harder. From a galaxy deep inside the Boötes void, the night sky is almost empty. That is the fact to start with, and it is worth being exact about, because it is the hinge of everything that follows. Our own sky is full because we have neighbours. Andromeda hangs 2.5 million light-years away, close enough to see with the naked eye as a faint patch of light, close enough that it is falling toward us. Beyond it there are dozens of smaller galaxies bound to us in the local group, and beyond them in every direction, the bright walls of the nearby universe, thousands upon thousands of galaxies that a modest telescope can pick out as smudges scattered across the dark. That is our sky. It is a crowded one. We were born on a thread of the web, where the company is close. Now stand on a world in that lonely spiral in the middle of the void. The galaxy itself is still there around you, its own 100 billion stars, wheeling overhead in a bright band, the same way our own galaxy makes a band across our sky. That much is the same, but look past it, out beyond your own stars, and there is almost nothing. The nearest large galaxy is not 2.5 million light-years away. It is tens of millions of light-years away, 10 or 20 times farther, and at that distance it is not a patch you could see by eye. It is not anything you could see by eye. It would take a real instrument, pointed carefully, a long exposure, to find it at all, and it would be one of only a handful of such faint smudges in the entire sky, where our telescopes find thousands of galaxies in any direction we point them. A telescope in the deep of the void would sweep across the dark and come back with almost nothing, a few dim scattered smears at the edge of detection, and between them emptiness. That is the sky the loneliest galaxy sits under, its own stars And then the dark, and the dark is not salted with other galaxies the way ours is. It is close to bare. Whatever exists on the worlds of that galaxy, if anything exists there at all, came up looking at a universe that appears to be one galaxy and then nothing. Not a universe that is obviously full and obviously enormous, the way ours announces itself the moment you build a telescope and look. A universe that looks finished at its own edges. A universe that gives no sign, to the naked eye or to an early instrument, that there is anything beyond the single island of stars you live in. I keep coming back to that, because we take the opposite situation completely for granted. We learned that the universe is enormous and full of galaxies almost as soon as we had the instruments to check, because the evidence was sitting right there in our sky, thousands of other galaxies close enough to find. The fullness was handed to us. It is hard for us to picture a thinking thing that looks up, builds the same instruments we built, points them at the sky with the same care, and finds almost nothing, because the galaxies that would have told it the truth are simply too far away across the emptiness to register. But that is not a strange or contrived situation. That is the ordinary view from most of the volume of the universe, because most of the volume is void, and from inside a void the rest of the universe is too far to see. The honest admission here is real, and I want to put it plainly. We have not stood under that sky. No one has. Everything I just told you about the view from inside the Boötes void is reasoned out from distances and brightnesses, from what we know about how far the nearest galaxies are and how faint a thing that far away would appear. It is a sound inference, and I am confident in the broad shape of it, that the sky inside a deep void is close to empty of other galaxies. But the details, exactly how much an instrument out there could pull out of the dark with enough effort, exactly where the line between visible and invisible would fall, those depend on specifics we do not have, because we cannot go and look. We are describing a sky we have to calculate rather than see. That is the honest limit on this part. Think about what our own instruments do, because the contrast is the whole point. Point a good telescope at any patch of our sky that looks completely dark, a piece of black with nothing in it, and hold it open. The dark fills with galaxies, hundreds of them, thousands of them, in a gap that looked empty, stacked back as far as the instrument can reach. That is what our sky is like. The fullness is so total that even the parts that look empty are crowded once you look harder. We could not have missed the truth about the universe if we tried. The moment we built instruments good enough to see faint things, the galaxies were everywhere we pointed, and the only possible conclusion was that the universe is enormous and packed with them. Now do the same thing from the deep of the Boötes void. Point the same telescope at the dark and hold it open. Almost nothing comes back. A few faint smears at the very edge of what the instrument can detect, scattered thinly, and between them, real emptiness, dark that stays dark no matter how long you hold it open, because there is nothing out there near enough to register. A galaxy tens of millions of light years away is many times farther than Andromeda is from us, and brightness falls off hard with distance, so a galaxy that far is not a smudge you catch by eye. It is a faint thing you have to work to find even with a real instrument, and there are only a handful of them in the entire sky. The view that taught us everything, the crowded dark that fills with galaxies the moment you look, simply does not exist from in there. So consider what that does to a civilization if one ever arose on a world deep in the void. It would build its astronomy the way we built ours, looking up, mapping what it could see. But what it could see would be its own galaxy, and then a sky that stayed empty under every instrument it built for a long time, because the nearest other galaxies were too faint and too few to find without enormous effort. It might go through its entire early history, develop its science, map its own stars in detail, and never once find convincing evidence that another galaxy existed, because the evidence was there only as a few smears at the edge of detection that you would have to be looking for, specifically and hard, to pull out of the dark. It might take such a civilization an extraordinarily long time to learn the thing we learned almost immediately, that the universe is full of galaxies. Some of them it might never learn at all. That is the difference between the rare seat and the common one. We were handed the scale of the universe for free because our sky shouts it. The void sky whispers it, so faintly that you could miss the whisper for the whole life of a civilization. A universe that looks finished and small at its own edges, that gives no easy sign of anything beyond the single island you live on, is not a trick or a contrived scenario. It is the honest view from most of the volume of everything. And here is a thing that is easy to get wrong, so let me be clear about it. A galaxy in the deep of a void is not itself a dead or barren place. The lonely spiral in the middle of the Boötes void is on the inside an ordinary galaxy. It has its 100 billion stars, its spiral arms, its clouds of gas, its worlds, whatever those worlds may hold. Nothing about being in a void reaches inside a galaxy and hollows it out. The emptiness is outside it, not within it. So if there were a world there with something living on it, that thing would not feel as though it lived in a barren universe. It would have its own sun, its own sky full of its own galaxy's stars, the same crowded band of light overhead that we have. Its days and nights would look normal. The only difference, the entire difference, is what lies beyond its own galaxy, and beyond its own galaxy there is almost nothing. The isolation is not a poverty of its immediate surroundings, it is a poverty of everything past them. Which is what makes the conclusion it would draw so natural and so hard to escape. It would not feel deprived, it would not look up at an obviously empty sky and wonder what went wrong. It would look up at its own rich band of stars, the same as we do, and find that beyond them the universe simply stopped, with a few faint smears at the edge of detection, and then nothing. And it would have no reason to suspect that the stopping was an illusion of distance rather than the real edge of things. It would not even necessarily think to ask whether it was alone, because aloneness would not present itself as a question. It would present itself as the plain background fact of existence, the unremarkable truth that the universe is your galaxy, and then the dark. You only ask whether you are alone when something hints that you might not be. The void sky offers no such hint. It is worth noticing how completely our intuitions were shaped by the rare sky we happen to get. Every picture we carry of the universe, every image of a field of galaxies stretching off in all directions, every sense that space is a crowded and populated place, comes from our vantage on a bright thread where it is. We built our whole feel for the universe out of the one kind of view that almost nothing else in it shares. If our intuitions had been formed in the deep of a void, the universe would feel to us like a single galaxy adrift in an enormous nothing. And that feeling would be the accurate one for most of the places there are. We think of fullness as the natural face of the universe, only because fullness is the face it happens to show us. Step off our thread, into the emptiness that is most of everything, and the natural face of the universe is a near empty sky, and our crowded one would look like the strange and special case it actually is. But the broad fact stands, and the broad fact is the one that matters. The dark we have been following, the dark that was one region and then became most of the universe, is now a sky. From inside the emptiness that is most of everything, the universe looks almost empty. The view from the common kind of place is a view of nearly nothing. And that sets up the question I have been walking us toward this whole time, the one that turns this from astronomy into something that sits heavier than astronomy. If something grew up under that empty sky, if a thinking thing arose on one of those marooned worlds and looked up and did its best to understand what it was looking at, what would it conclude? And here is the part that should bother you before I even answer it. Whatever it concluded, that conclusion, drawn from the common view from the sky that most of the universe actually has, would be the normal one. Ours would be the strange one. So what does the universe look like to almost everything that could ever look at it? And what does it mean that the answer is nothing? It would conclude that it is alone. That is the answer, and the worst part of it is that the conclusion would be reasonable. Put a thinking thing in the deep of the Boötes void, give it our curiosity and our patience and our instruments, and let it do everything right. It looks up, it maps the handful of faint galaxies it can find. It measures them, counts them, studies them, and finds nothing beyond them, because there is nothing beyond them within reach of what it can see. And from that evidence, gathered carefully and read honestly, it concludes that the universe is small, that its own galaxy and a few dim companions are most or all of what exists, and that it is, for all practical purposes, alone. Every step of that reasoning is sound. The conclusion is wrong, and it is wrong for one reason only, a reason the thinking thing could never have detected from where it sits. It happens to live in an empty place, and the rest of the universe is too far across the dark to show itself. I want to be careful with this, because it is easy to turn into a cheap chill, and it is worth more than that. The Void Dweller is not making a mistake. There is no error in its work, no failure of nerve or imagination, no step it skipped. It reaches the only conclusion the evidence supports, the same way we would in its position, and the universe simply does not give it the evidence that would correct it. The fullness that taught us the truth, the thousands of nearby galaxies that announced themselves the moment we looked, those are absent from its sky. It is not being fooled by a trick. It is being told the truth by everything it can observe, and the truth it can observe is a lie of omission, written by distance. It would build a complete, careful, self-consistent picture of a small and lonely universe, and it would have no way, none, to know that the picture was the local view from inside a hole. Now here is the turn, and it is the heaviest thing in this whole video, so I am going to say it slowly. That view, the view from the deep of the void, the sky that looks empty, and the conclusion that one is alone, is not the rare case. It is the common one. We established it already, but let it land now with its full weight. Most of the volume of the universe is void. Most of the space there is to exist in is deep inside one of these empty cells. So most of the vantage points there are, most of the places a thing could ever look up from, are places where the sky looks close to empty, and the honest conclusion is that one is alone. The crowded sky, the full sky, the sky that hands you the truth about how enormous and populated the universe is, that sky belongs to the thin, bright strands of the web, and the strands are the exception. The typical view of the universe, from a typical place in it, is a view of almost nothing, which means we have had it backwards in the deepest possible way. We treat loneliness as the universe's tragedy, the sad possibility, the thing we hope is not true, the silence we keep listening into and dreading. But loneliness is not a possibility the universe might fall into. It is the universe's ordinary condition. It is the default view from most of the places that exist. The strange thing, the rare thing, the thing that actually needs explaining, is not the emptiness. It is us. It is the full sky. It is the accident of having been born on one of the few bright threads where the company is close enough to see, so that the truth about the universe was lying around in plain sight for us to find. We did not earn that view. We did not reason our way to a crowded universe against the evidence. We were handed a crowded sky by the luck of our address, and almost nothing else in the universe gets that luck. That is the part one cannot put down. We have spent so long treating our situation as the normal one, and the empty places as the exception, when it is exactly the reverse. If you picked a place in the universe at random, truly at random, weighted by volume, you would almost certainly land deep in a void, under an empty sky, with every reason to believe you were alone, and no way to learn otherwise. You would be the Void Dweller, the crowded, reassuring, obviously enormous universe that we take as simply given, is a thing almost no possible observer ever gets to see. We are not looking at the universe the way it usually gets looked at. We are looking at it from one of the rarest vantage points there is, and mistaking the view from it for the view everyone has. The honest admission is important here, and I do not want to oversell past it. I have been talking about a thinking thing in the void, an observer, a mind that looks up and concludes it is alone. We do not know that any such thing exists in the Boötes void or anywhere else. We have no evidence of minds out there, in voids or on bright threads or anywhere at all. So I am not telling you the voids are full of lonely thinkers staring into empty skies. The loneliness I am describing is not a census of sad observers. It is the geometry of the universe itself, the plain fact that most vantage points are empty ones, whether or not anything is standing at them to feel it. But I would push back gently on the idea that this makes it lighter. The geometry is the unsettling thing on its own. The universe is arranged so that almost every possible view of it is a view of nearly nothing. That is true whether or not anyone is there to be lonely. It is a fact about the shape of everything. And the picture that thinking thing builds would not be a rough sketch with obvious gaps. It would be complete. It would be consistent. Every test it could run would confirm it. It would map its own galaxy in exact detail, work out the laws that govern its own stars, measure everything there is to measure from where it sits, and all of it would fit together into a closed, careful account of a small universe in which it is alone. There would be no loose thread for it to pull, no anomaly nagging at the edge of the data, because the thing that would correct it, the rest of the universe, leaves no mark on its instruments at all. It would not be a civilization that failed to find the truth. It would be a civilization for which the truth was sealed away behind a distance no signal it could detect ever crossed. It would know everything about its own island and have no way to suspect there was anything else, and it would be wrong, completely, about the size and the fullness of the universe, with a cosmology that worked perfectly for everything it could ever check. And here is the cleanest way I can put how common that situation is. Suppose you could scatter observers evenly through the actual universe, not evenly across the galaxies, but evenly across the volume, one for every equal region of space. Almost every one of them would open its eyes deep inside a void, under an empty sky, with a few faint smears at the edge of sight, and nothing else. The observers who open their eyes on a bright crowded thread, with a companion galaxy hanging close, and a sky that fills with galaxies the moment they look, would be a tiny minority, because the bright threads are a tiny fraction of the volume. The standard view of the universe, weighted by where there is room to stand, is the empty one. We are not a representative sample of one. We are the rarest kind of observer there is, and we have built our entire understanding of how normal our situation is on the assumption that we are typical. We are the opposite of typical. We are the exception that got lucky enough to see the truth, surrounded by a universe in which the rule is to see almost nothing. And I want to be exact about the word alone, because the void dweller would not even be wrong in the way that matters most. Set aside whether its conclusion is technically false, in any sense it could ever act on, in any sense that touches its actual existence, it really would be alone. The other galaxies are so far across the emptiness that nothing it could ever build would reach them. No signal it sent would arrive anywhere near them. No signal they sent would carry to it with any strength. They are out of reach in every practical meaning of the word. So the void dweller, concluding that it is alone, is making an error about the bare existence of other galaxies, and at the same time saying something almost exactly true about its real situation. It is alone, for all purposes that matter, even though the universe is full. And that, the fact that fullness and total isolation can be true at the same time about the same place, is the thing the void teaches that I find hardest to put down. And notice that this does not even depend on the universe being empty of life. Suppose the opposite. Suppose the universe is full of it, that life arises readily wherever it can, on worlds beyond counting. Most of those worlds would still be in voids, because most of the volume is void, and most of that life would still look up at a near-empty sky and reasonably conclude it was alone, and most of it would be right in every way that touched its existence, because the rest of the living universe would be sealed away behind the same emptiness, unreachable and undetectable. The arrangement of the universe does not just hide galaxies from each other, it would hide life from life, mind from mind, each one marooned in its own cell, with the others too far across the dark to ever know about. So the universe could be both crowded with life, and a place where nearly everything alive in it spends its existence convinced, reasonably, that it is alone, and never finds out otherwise. The loneliness is not a statement about how much is out there. It is a statement about how the universe is built. It isolates whatever it contains by its plain geometry, whether that is almost nothing or almost everything. There is a way of stating this that I think is the truest thing the Boötes void has to teach, and it is about the relationship between emptiness and knowledge. What you can know about the universe depends on what has been able to reach you, and what reaches you depends on what is near enough across the dark. In a full place on a bright thread, a great deal is near enough, and so a great deal can be known. In an empty place, almost nothing is near enough, and so almost nothing can be known. The universe therefore hands out understanding in proportion to fullness, and it is mostly empty, so it mostly hands out almost nothing. The typical condition of a knower in this universe is to be sealed inside an emptiness that allows it to learn its own small island and nothing beyond. We are not in that condition. We are in the rare condition where enough is near enough that the truth could be assembled, and we did assemble it, and we are proud of having assembled it, as we should be. But we should be clear about how much of that achievement was the luck of the address. Most possible knowers, in most possible places, could do everything we did exactly as well, and still come up with a small and lonely universe, because the universe would have sealed the rest away from them by simple distance. So when we look at the void dweller and feel the chill of its reasonable, total, mistaken certainty that it is alone, we should understand that we are not looking at an unfortunate exception. We are looking at the standard outcome, the thing the universe produces almost everywhere, the ordinary result of being a mind in a mostly empty place, and we are the exception to it, the rare knower who got a full enough sky to see past its own island. We did not earn that by being clever. We were clever, but clever was not enough and never could have been anywhere else. We earned it by being born in one of the few places that let cleverness work. That is not a comfortable thing to know about your own understanding, that its reach was set less by your effort than by your address, but it is the honest thing, and the void is what makes it plain. And there is an asymmetry here that is worth naming, because it is the one advantage our rare seat gives us, and it is a strange one. We can see into the voids. From our bright thread, with the rest of the universe laid out around us, we can look across at the Boötes void, map its emptiness, count its 60 galaxies, understand what it is. But the void dweller cannot look out. From inside the emptiness, the bright universe is too far across the dark to read, so the understanding only runs one way. The full places can comprehend the empty ones, but the empty ones cannot comprehend the full. We know about the void. The void, if it could know anything, could not know about us. And since the empty places are most of the universe and the full places are the rare exception, that means understanding of the whole is available almost nowhere, from almost no vantage point, except the few bright threads. We are not just lucky to see a full sky, we are among the only places from which the arrangement of the entire universe, the full and the empty both, can be seen and understood at all. Almost everywhere else, the understanding simply is not available, because almost everywhere else is sealed inside an emptiness that only shows you yourself. So that is the spike, the bottom of the drop, the place the whole argument has been falling toward. Emptiness is the default. Loneliness is the ordinary condition. The full sky is the rare exception, and we are sitting in it, mistaking our luck for the rule. Now, all of this emptiness might still feel safely far away to you, a fact about a distant region in Boötes and about hypothetical minds that may not exist. It is not far away. Keep one question in your mind, because I am going to answer it shortly, and it is the part that stops being about a distant void and starts being about us. If voids are the rule, and if they are still growing, then where is the nearest one, and what is it already doing to us right now? Hold that. I am coming back to it, and the answer is closer than you want it to be. First though, I have to show you the thing I just slipped into that question, the part where I said the voids are still growing, because that changes everything about what they are. A void is not a finished thing. It is not a hole that opened once and now sits there, stable, a fixed feature of the map. The Boötes void is still emptying. It is larger now than it was 1 billion years ago, and it will be larger still 1 billion years from now. And the reason why is the same force that is doing the strangest work in the universe at large. Inside a void, the thing in charge is dark energy. Let me lay that out because it is the engine of the back half of tonight. Dark energy is the name we give to a faint outward pressure that belongs to empty space itself. Every region of space carries a little of it, a slight push that wants to drive things apart, and across the universe as a whole it is the dominant ingredient, something like 70% of everything there is. We do not know what it is. That is not me softening the point. It is the honest state of it. We can measure what it does with great precision, and we cannot tell you what it is made of or why empty space should push at all. What matters for tonight is where it does its strongest work, and the answer is the voids. Inside a region like the Boötes void, where matter is so thin that its gravity is almost nothing to pull with, there is nothing left to oppose that outward pressure. Out on our bright thread, gravity still has plenty of matter to work with and holds things together against the push. In the deep of a void, the matter is too sparse to resist, and so the void is the one place where dark energy gets to do exactly what it wants, with nothing standing in its way. What it wants is to expand, so voids expand, and they expand faster than the universe as a whole. A void is not just sitting there empty, it is actively blowing itself larger, pushing its own boundaries outward against the walls that surround it. And as it pushes outward, it presses on those walls, the bright sheets of galaxies that fence it in, and it thins them. The matter in a wall between two voids gets squeezed and stretched as the voids on either side both push against it, and over long enough spans the wall thins out, loses its galaxies to the denser knots, and finally gives way. When that happens, the two voids on either side of it stop being two voids. They merge into one larger emptiness, and the dividing wall becomes a few stray galaxies strung across the inside of the new bigger void, the only trace that there were ever two. That is almost certainly part of the story of the Boötes void itself. Remember the structure threaded across its middle, the reason we think it may be several voids that ran together. This is how that happens. Smaller voids, each draining on its own, grow and push and thin the walls between them until the walls dissolve and the separate emptinesses become one great emptiness, with the ghosts of the old walls still hanging inside it. The Boötes void may be the merger of 2 or 3 such regions, and if it is not finished merging with the universe around it either. It is still pushing on its own bright walls, the Hercules and Corona Borealis and Boötes superclusters, still thinning them, still growing. So the bright web, the lacing of galaxies we live in, is not a permanent scaffold. It is being pulled apart from the inside by the emptiness it surrounds. The voids are not the gaps left over between the strands. They are active. They are the thing doing the pulling. Every void in the universe is slowly inflating, pressing on its walls, thinning the bright structure, working to merge with its neighbours into something larger and emptier. The web is not getting more intricate over time. It is coming apart. The strands are thinning and the cells are growing, everywhere, at once, and the agent doing it is the same outward pressure of empty space that fills the voids precisely because the voids have nothing else in them. The honest admission here is a real one, and it is the same one that haunts the far future of any story that involves dark energy. All of this, the growing voids, the thinning walls, the web coming apart, depends on dark energy continuing to behave the way it behaves now. We are taking the outward pressure we measure today and running it forward, assuming it holds steady. That is the best reading of the evidence we have, and it is a good reading. But dark energy is the thing we understand least in all of this, and if it turns out to change over time, to weaken or strengthen, or do something we have not anticipated, then the long-term picture changes with it. So when I tell you the voids keep growing and the web keeps thinning, hear the honest version. Under the physics we can measure now, that is the direction, clearly and strongly. Whether it holds all the way to the end is a question with a real edge of uncertainty on it, because it rests on the one ingredient we cannot yet explain. It is worth being clear about why the voids, of all places, are where this outward pressure wins, because it is not obvious, and it is the key to the whole back half. Dark energy is spread evenly through all of space, the same faint push everywhere, in the voids and on the bright threads alike. The difference is what it is up against. On our thread, and in every wall and cluster, there is enough matter that gravity has real strength, and gravity pulls inward, holding things together against the outward push and winning easily on local scales. That is why our galaxy is not flying apart, why the local group will hold. But in the deep of a void there is almost no matter, so there is almost no inward pull, and the faint outward push has nothing to overcome. The same pressure that loses to gravity everywhere there is stuff to pull, wins by default everywhere there is not. The voids are not where dark energy is stronger, they are where nothing is left to resist it. So the voids are the one kind of place in the universe where the outward pressure runs unopposed, and an unopposed push, given billions of years, expands the void faster than the universe around it is expanding. That extra speed is the thing that matters, because it means the voids are not just being carried along by the general expansion of the universe, they are gaining. A void grows faster than the average, which means its share of the total volume increases over time. The universe is not just getting bigger everywhere at the same rate, with the voids and the walls keeping their proportions. The voids are winning volume from the bright structure, year over year, age over age, and as each void inflates faster than its surroundings, it presses harder on its own walls, and a wall pressed on from both sides by two growing voids eventually gives, its matter draining into the denser knots, until the wall is gone and the two voids are one. The largest voids in the universe, the Boötes void among them, are very likely the survivors of exactly this, the mergers of smaller voids that grew into one another and swallowed the walls between. And they are not done. They are still growing, still pressing, still working to merge with the next emptiness over. So the long-term trend of the cosmic web is not toward more structure, it is toward less. Over time there are fewer voids because they keep merging, but each one is larger because the survivors absorb their neighbours. The walls thin, the threads fray, the intricate web of bright structure simplifies steadily toward a smaller number of enormous emptinesses with thinner and thinner bright material strung between them. The universe is not building itself into something more elaborate as it ages. It is being hollowed out, the bright structure retreating onto fewer and thinner strands while the dark cells swell and merge and take more and more of the volume. The Boötes void is a snapshot of that process well along, and the process is running everywhere, and it is running in one direction only. And it does not reverse. That is the quiet, final thing about the growth of voids, and it is worth saying outright. Once a region has drained, it does not refill. The matter that left the Boötes void for the walls is not coming back, because the same outward pressure that emptied it keeps pushing, and the gravity that might have drawn matter back in is exactly what the void no longer has enough matter to provide. A void is not a low point that the universe will eventually fill back in. It is a one-way condition. Every age it is emptier than the last, never fuller, and the same is true of every void everywhere. The bright structure is not cycling, draining and refilling and draining again. It is draining, only draining, on a one-way course, the matter collecting onto fewer and thinner strands, while the emptiness grows and never gives anything back. There is no return stroke. The universe sorts itself into full and empty, and the empty only ever wins more ground. And we are not only inferring this growth from theory, we can see it, because looking far across space is the same as looking back in time. The light from a distant region left it long ago, so when we map the structure of the universe at great distances, we are seeing it as it was when the universe was younger. Do that, and the pattern is clear. In the younger universe, the voids were smaller and shallower, the bright structure more evenly spread, the sorting less complete. Closer to us, in more recent times, the voids are larger and emptier, and the structure is pulled into sharper threads and walls. The progression from the early universe to now is a progression of emptying, the voids deepening and widening as time runs forward, the contrast between full and empty sharpening. We are watching the growth happen, spread out across the distances of the sky, the early shallow voids far away, and the deep modern ones near at hand. The Boötes void is what a void looks like well along in that progression, and the progression has not stopped. It is the state of the universe now, and the universe now is still sorting. Step back far enough, and the bright web turns out to be a phase, not a permanent feature of the universe. In the beginning there was no web at all. Matter was spread almost perfectly smoothly, no threads, no walls, no voids, just a nearly uniform haze. The structure we see now, the whole intricate arrangement of filaments and clusters and the dark cells between them, was built over billions of years by the sorting out of that smooth start. And the sorting does not stop at the web. It keeps going past the web toward emptiness, the voids growing and merging and the bright structure thinning toward fewer and thinner strands. So the cosmic web is a passing phase. It had a beginning when the smooth early universe first started pulling itself into structure, and it has an end when the emptiness has grown enough to pull that structure apart. We happen to be alive during the stretch of time when the web exists, when there is bright structure to live in and a full sky to look at. That phase is not the permanent state of the universe. It is the brief, structured middle between a smooth beginning with nothing in it yet and an emptied end with the structure drained away. The fullness we take as simply how the universe is a passing condition of one phase, and the phase is already turning. But the direction is not in serious doubt, and the direction is the unsettling part. The dark is not static, it is growing. The Boötes void is bigger every age, and so is every other void, and the bright places are thinning to feed them. Which brings me back to the question I asked you to hold. If voids are the rule, and if they are still growing, pushing on their walls, swallowing their neighbours, then where is the nearest one to us, and what is it doing right now? I told you the answer was closer than you would want. Here it is. The nearest void is not in Boötes, and it is not at a safe distance, and it is not leaving us alone. There is a void at the edge of our own neighbourhood. It begins more or less right at our doorstep, where the galaxies of our local region thin out into a large underdense region that reaches at least 150 million light-years across, and probably more. We call it the local void, which is a flat name for a thing that should unsettle you more than it does. We are not at a safe distance from the emptiness. We are on the shore of it. Our own small neighbourhood of galaxies, the local group, sits on the bright edge of a large void, and we are looking out across it, the way the galaxies on the rim of the Boötes void look out across theirs. And it is not leaving us alone. This is the part that took me a while to absorb when I first sat with it, because it overturns something I thought I understood. Our galaxy is moving. The whole local group is moving, all together at about 630 kilometers every second, relative to the background light of the universe, the faint even glow left over from the early universe that fills all of space and gives us a fixed reference to measure our motion against. 630 kilometers a second is more than 1,000,000 miles an hour. We are not sitting still in space. We are being carried through it, fast, in a particular direction, and for a long time the natural assumption was that we were being pulled, that somewhere off in the direction we are heading there was a great concentration of mass, and its gravity was reeling us in. There is some truth to that. There is a great concentration of mass in roughly that direction, an enormous dense region called the Shapley concentration, far off, and it is pulling, but the pull does not account for all of our motion, and the missing part is the part that matters tonight. When the map of what surrounds us is worked out carefully, our motion turns out to be only half a pull. The other half is a push. Behind us, on the side we are moving away from, there is a large underdense region, an emptiness, and we are being driven away from it. This emptiness has a name now, the dipole repeller, and it is doing to us exactly what the word says. It is repelling us. We are being shoved out of the empty side of our surroundings and toward the full side, and the push from the emptiness is about as strong as the pull from the distant mass. Sit with that, because it is genuinely strange, and it is genuinely true. An empty region pushes. Not because emptiness is a force. It is not. There is nothing in a void to do any pushing in the ordinary sense. It is that everything else is being pulled toward the dense regions, and a void is the place with the least to pull you, so relative to everything around you, you drift away from the emptiness and toward the crowd. The net effect, the thing we actually measure in our motion, is indistinguishable from being pushed. The void behind us shoves us forward as surely as the mass ahead of us pulls. Emptiness, it turns out, is not passive. It does not just sit there being absent. It leans on its neighbours. It has shaped the motion of our entire galaxy, our whole local family of galaxies, for the age of the universe. And it is shaping it right now, this second, carrying us along at over 1,000,000 miles an hour, half of that a push from the dark. So the emptiness is not a distant thing we study from safety. We are on the edge of a void. We are being pushed by another one. The dark we have been following all night. The dark that was one region in Boötes, then the body of the universe, then the empty sky over the lonely galaxy, has arrived at our own address. It is here. It is touching us. It has its hand on our galaxy, and it is pushing. The honest admission is necessary, because this is a place where the confidence has to be calibrated carefully. The fact that we are moving at 630 kilometers a second is rock solid. We measure it directly against the background light, and it is not in doubt. The split of that motion into a push and a pull, and the mapping of the emptiness behind us, the dipole repeller, is newer and harder, because mapping a void means mapping the absence of galaxies, and you have to map carefully to be sure an absence is real and not just a region you have not surveyed well. Some of the underdense region that pushes us is hidden as it happens behind the dense band of our own galaxy, which blocks our view of part of the sky. So the push is measured and the broad picture is sound, but the detailed map of exactly what is empty behind us, exactly how deep and how wide, is still being filled in. What is certain is that we are moving fast, that part of that motion is a push from an underdense region, and that we sit on the edge of a void of our own. The exact shape of the emptiness around us is the part still being drawn. Let me be specific about the void at our edge, because the specifics are what make it real. We sit on a broad, flat sheet of galaxies, a bright surface that forms one boundary of the local void, and the local void opens out on the other side of that surface, beginning essentially where our own neighbourhood ends. We are not in the middle of a crowded region with the nearest emptiness comfortably far off. We are on the wall, and we are being pushed off it. The local void is doing what every void does, emptying and growing, pressing on the bright surface we live on, and the measured result is that our own small sheet of galaxies is being driven away from the local void at something like 260 kilometers every second. The emptiness next door is shoving us, right now, at a speed we can put a number on. For a long time we did not read it that way. We knew our galaxy was moving fast, the whole local group sliding through space at 630 kilometers a second against the background light. And the assumption was that we were being pulled, that the motion pointed towards some great mass whose gravity was drawing us in. There were candidates, a dense region in the direction we are heading, and farther off the enormous Shapley concentration, and they are real and they are pulling. But when the surroundings were finally mapped with enough care to add up all the pulls, they did not account for our full motion. The sums came up short, and the missing push was coming from behind us, from the side we are moving away from, where there was not a great mass but a great emptiness. That emptiness is the dipole repeller, and adding it in closed the gap. About half of our motion is the pull of distant mass ahead. The other half is the push of emptiness behind. I called it a push, and I want to be careful because emptiness is not a force and does not literally push anything. What happens is simpler and stranger than a force. Everything in our region is being drawn toward the dense places, and a void is the place with the least matter to draw you. So compared to everything around us, we drift away from the void and toward the crowd. The emptiness does not reach out and shove, it simply fails to hold us the way the dense regions pull us, and the net of all those pulls and absences is a motion that points away from the empty and toward the full, at a speed we measure as more than 1,000,000 miles an hour. Add it up however you like, and the result is the same. The arrangement of full and empty around us is carrying our entire galaxy through space, and a full half of that motion traces back to the emptiness we are being driven out of. So we are not observers at a safe remove from the voids. We live on the wall of one and we are being driven by another, and the same sorting that emptied the Boötes void, the draining of the thin places and the pushing of their walls, is the thing that has our galaxy in its grip and has had it for the age of the universe. The dark is not a thing happening elsewhere to other galaxies. It is the thing setting the motion of our own. There is a larger and more uncertain version of this that is worth putting on the table honestly, because it sharpens the point even though it is not settled. The local void is the emptiness right at our edge. But there is evidence, debated but real, that our entire broad neighbourhood, a region a couple of billion light years across, sits on the thin side of average, inside a large shallow underdensity, a region where the density of galaxies runs maybe 20% below the cosmic norm, out to enormous distances. If that is right, then it is not only that there is a void at our doorstep and another at our back, it is that the whole region we live in is itself a mild void, a large underdense bowl, and our bright local thread is an island of fullness, sitting inside a much larger emptiness that we are only beginning to map. I want to flag clearly that this larger local underdensity is not nailed down the way the local void and our measured motion are. It is an active question, supported by some measurements and contested by others, and reasonable people are still arguing it. But if it holds, it would mean we are not perched on the edge of the emptiness looking in. It would mean we are already inside one, a shallow early one, near the bright rim of it, and that the emptiness we have been treating as the thing next door is in fact the thing we live in. We may be void dwellers already, and simply too early in the draining to feel it. And none of it is something we feel. That is worth pausing on, because it is part of why the emptiness is so easy to ignore. We are being carried through space at more than 1,000,000 miles an hour, half of it a push from the emptiness behind us, and there is no sensation of it at all. No wind, no force, no sense of motion. The push works on our whole galaxy at once, every star in it moving together, so there is nothing to feel it against. We worked out that we are moving this fast, and worked out that a void is doing half the pushing only by measuring our motion against the faint background light of the early universe, the one fixed reference there is. Without that, we would have no idea we were moving at all. The emptiness is not only invisible to the eye, a dark we cannot see into. It is invisible to every sense we have. It shapes the motion of everything we are and gives no sign of doing it. We had to deduce that the void had its hand on us. We will never feel it. That is the quiet horror of the thing, if there is one. Not a void that announces itself, that we could point to and brace against. A void that moves us without our knowledge, that we share an address with and are driven by, and would never have suspected if we had not learnt to read our motion against the oldest light in the sky. The emptiness next door is not a distant fact we observe. It is a present force we are subject to, and the only reason we know it at all is that we looked very carefully at a faint glow and found our own speed written in it. And there is a final turn of the knife in our own motion, which is that it leads nowhere we can ever arrive. We are being pushed by the emptiness behind and pulled by the dense Shapley concentration ahead, moving at more than 1,000,000 miles an hour along a definite course. But the place we are heading toward, That distant concentration of mass is so far away, and the universe between us and it is expanding so steadily that we will never reach it. Our whole local family of galaxies is being driven across space toward a destination it can never arrive at, because the expansion of the universe opens the distance faster than our motion closes it. So the push and the pull are real, our speed is real, our direction is real, and the destination is forever out of reach. We are in motion toward a place we cannot get to, driven by an emptiness we cannot feel, on a course set by the arrangement of full and empty around us. That is our actual situation in the universe, stated plainly, and it is stranger and emptier than the still, safe, central position we tend to assume we occupy. But the core of it is settled, and the core of it is the thing that closes the distance this whole video has been closing. The voids are not out there. One of them is here, at our edge, and another is at our back, pushing, which leaves the last question, the one everything has been building toward. If we live on the shore of one void and are being pushed by another, if the bright places are thinning to feed the dark and the dark is growing and merging and leaning on its neighbours, then where does this go? Not for the Boötes void, for us, for the bright thread we live on, the full sky we were lucky enough to be born under. What happens to it, given enough time? That is the last thing I have to show you before we can say what the void actually is. The bright places go the way of the void. That is where this ends, and it is not a guess pulled from nowhere, it is just the same process we have been watching, run forward. The voids grow. They have been growing for the entire age of the universe, and the physics that drives them is not slowing down, it is speeding up, because dark energy strengthens its grip as the universe expands and thins. So run the clock forward, and the voids keep inflating, keep pushing on their walls, keep merging with their neighbours, and the share of the universe that is empty climbs and climbs. The bright web does not hold, the threads thin, the walls dissolve, the lit structure that holds the galaxies gets pulled apart from inside by the emptiness it surrounds. The same way the walls inside the Boötes void were pulled apart, until more and more of the universe is bare. And our thread is not exempt. That is the part there is no comfortable way around. We sit on one of the bright strands, with our close company, our local group, the few dozen galaxies bound to us tightly enough by gravity that they will stay. Those will hold. Andromeda is falling toward us and will eventually merge with our galaxy. And the bound family around us will draw together rather than apart, because inside a gravitationally bound group, the local pull still beats the outward push. But everything past that bound family is a different story. The wider company, the nearby groups and clusters that fill our sky beyond the local group, the bright neighbours that make our region look populated, those are not bound to us. They are being carried away by the same expansion that grows the voids, drifting outward, receding, thinning, over long enough spans the bright thread we live on phrase. Our neighbours recede past the point of reach, and then past the point of sight. The sky here empties, slowly, from the outside in, until what is left is our own merged galaxy, and a great surrounding dark, and the dark goes on without the company that used to fill it. Which is to say, the view from here, given enough time, becomes the view from inside the void. The empty sky over the lonely galaxy, the one we stood under a few minutes ago and thought of as a distant and alien condition, is not distant, and it is not alien. It is our own future sky. We are not the opposite of the Boötes void. We are an earlier stage of the same thing. The void is not the exception to a universe like ours. A universe like ours, bright and full and close, is a passing phase on the way to a universe like the void. The emptiness is not where we are not, it is where we are going. Let me put the time scale against something human, because the numbers are so large they go numb otherwise. None of this is fast. The thinning of our sky plays out over spans that make the entire history of the universe so far, all 13.5 billion years of it, look like an opening moment. The sun has billions of years left before it dies, and that is nothing against the time it takes for our bright region to drain toward emptiness. We are not standing at the edge of this. We are near the very beginning of it, in the brief, bright, early phase when the web is still full and the company is still close and the sky still hands you the truth about how enormous and populated the universe is. That phase is not the permanent condition. It is the opening one, and we happen to be living inside it. The long story of our region is the same story as the Boötes void, the slow draining of a bright place into a dark one, and we are simply near the start of ours, rather than far along like the void is along its own. The honest admission is the same one as before, and it has to be stated again because the stakes are higher here at the end. This is an extrapolation. It runs the physics we measure now forward across enormous spans of time, and it rests, like everything in the back half of tonight, on dark energy continuing to behave as it does today. The direction is clear and strongly supported. The exact pace, the exact endpoint, how completely the bright place is empty, and how long it takes, those carry real uncertainty, because they depend on the one ingredient we cannot yet explain holding its character all the way out. So here the calibrated version. Under the physics we can measure, the bright place is thin and drained toward emptiness, and our own is no exception, and the void is the direction. Exactly how far and how fast is the part with an edge of doubt on it, that the direction is toward the dark is not the doubtful part. It is worth being precise about what holds and what does not, because the future is not a uniform fading, and the difference is the point. Our close family, the local group, the few dozen galaxies bound to us tightly by gravity, will hold together. More than that, it will draw inward. Andromeda is falling toward us, and in a few billion years the two great spirals will meet and merge into a single galaxy, and the smaller bound members will fall in over time as well, until our whole local family has become one combined island of stars. That much survives, because inside a bound group the local pull beats the outward push, the same way it does inside any galaxy. So the future is not that everything drifts apart. The future is that our bound family merges into one, and everything outside that family leaves. And everything outside that family is most of what fills our sky. The nearby groups and clusters, the bright neighbours beyond the local group, the structure that makes our region look crowded, none of that is bound to us. All of it is being carried away by the same expansion that grows the voids, receding, dimming, drifting past the point where we could reach it, and then past the point where we could see it. So run our own region forward and the picture is clear enough. Our bound family collapses into a single galaxy, and around it the sky empties, the neighbours receding into the dark one by one, until what remains is one island of stars and a great surrounding emptiness with almost nothing in it, which is the void sky. It is exactly the sky we stood under at the middle of tonight, the sky over the lonely galaxy in the deep of the Boötes void, its own stars, and then near nothing. We become that galaxy. Given enough time, the view from our own merged island is the view from inside a void, because by then we will effectively be inside one, our neighbours gone and the emptiness grown up around us. And anything living in our galaxy then, looking up, would do exactly what the void dweller does. It would map its own stars, find almost nothing beyond, and conclude, reasonably and wrongly, that the universe is small and that it is alone. We spent the middle of this video looking at that lonely galaxy as a distant and alien thing, a vantage point belonging to some other unlucky island in some far-off emptiness. It is the seat we are walking toward. We are going to be the lonely galaxy. We are simply early. And early is the word because the timescale is the one piece of mercy in this, if you can call it that. None of this is soon. The bright phase we live in, the full sky, the close company, lasts for spans that make the whole history of the universe so far look like an opening instant. The sun will die long before our sky empties, and the sun's death is itself billions of years off. We are not at the edge of the emptying. We are at the very beginning of it, in the brief bright opening when the company is still close and the sky still tells the truth. But the beginning of a process is still the same process. The bright phase is not the permanent condition of our region. It is the opening stage, and the later stages drain toward the dark, and the void is just a region that is further along the same process than we are. And the part that closes the loop with the middle of tonight is this. Whatever is alive in our merged galaxy in that far future, looking up at its emptied sky, will be in exactly the position of the void dweller we spent so long on. It will map its own stars, find almost nothing beyond, and conclude, carefully and correctly on its evidence, that the universe is small and that it is alone, and it will be wrong in the same way and just as unable to know it, because by then the galaxies that would have told it otherwise will have receded so far that not one of them leaves a mark it can detect. The evidence that the universe was once bright and full and close, the evidence we have sitting in our sky right now, will be gone, carried past reach and past sight, and there will be no way for anything in our galaxy then to recover it. They will build a complete, careful, self-consistent picture of a small, lonely universe, exactly as the Void Dweller does, and exactly as wrongly, and nothing in their sky will argue with them. So we are not only heading toward the Void Dweller's sky, we are heading toward the Void Dweller's ignorance, the sealed and reasonable and totally mistaken certainty that one is alone in a small universe. The only difference between us and them is when we happen to be alive, we are early enough that the sky still tells the truth, that the galaxies are still close enough to see, that the fullness is still on display. They will be late enough that all of it has drained away. The truth about the universe is not only rare in space, available from only the few bright threads. It is rare in time, available only in the brief early stretch before the emptying carries the evidence off. We have the truth because we are early and we are lucky. Neither of those lasts. Let me put a number on the emptying, because the time scale is part of why it is so easy not to feel. The external galaxies do not vanish from our sky next age or next eon. The process that carries them out of view runs over something on the order of 100 billion years and beyond, a span against which the current age of the universe, 13.5 billion years, is a small fraction, and against which the entire history of life on Earth is nothing at all. We are talking about a future so distant that the sun will have died many times over before it arrives. So this is not a fear for tonight or for any night anyone will ever live to see. It is not a threat in any human sense, but it is a direction, and the direction is fixed, and the distance of it does not change what it is. The sky empties, it empties slowly, over spans that dwarf everything, but it empties, and the endpoint is a single island galaxy in a dark with almost nothing else in it. The slowness is real and worth stating plainly. It is also not comfort. A thing does not stop being true because it is far off. It only stops being urgent. The emptying is not urgent, it is certain. So the Boötes void is not a freak we get to study from the safety of a full sky. It is a preview. It is what most of the universe already is, by volume, and it is what the bright places, ours included, are slowly becoming. We are not looking across a gap at something alien, we are looking across time at something familiar, the same draining that built every void in the universe, caught at a later stage than our own. Which leaves only the honest question of what to make of that. We have walked all the way into the void and out the other side. We know what it is now, how it formed, how common it is, what it does, and where it points. So let me say as plainly as I can what I think it actually means. So here is what the Boötes void actually is, with everything we have gathered laid side by side. It is a region about 330 million light-years across that holds 60 galaxies where there should be 2,000. It got that way by draining itself slowly, by ordinary gravity, nothing destroyed and nothing taken, its matter migrating out to the bright walls that fence it. It is not rare, it is the nearest large example of the most common kind of place there is, because most of the volume of the universe is voids exactly like it, and the bright, crowded web is the thin exception laced through all that emptiness. From inside it, the sky looks close to empty, and anything that grew up there would reasonably conclude it was alone. And that view, the lonely one, is the common view, the one most possible vantage points in the universe actually have. It is not finished. It is still growing, pushed larger by the dark energy that dominates wherever matter is too thin to resist, thinning its walls and merging with its neighbours. And it is not unique to Boötes. There is one at our own doorstep, and another at our back pushing us along at over 1,000,000 miles an hour. And the bright thread we live on is on the same slow road into the dark that the void travelled long ago. Notice how far the word terrifying has moved over the course of all this. We started with the kind of terror the title promises, the terror of a mystery, a hole that should not be there, a wound in the sky that something must have made. That terror is gone because there is no mystery and no wound. Nothing made the void. It made itself by the plainest physics there is, and it is one of countless others, and it is ordinary. If the story ended there, the honest reaction would not be terror at all. It would be the opposite, a kind of relief, the settling that comes from finding out a frightening thing is actually mundane. But the story does not end there, and the terror does not disappear. It moves. It detaches from the idea of a strange hole and reattaches to something much larger and much harder to set down, which is that the mundane thing, the ordinary emptiness, is the rule, that it is most of the universe, that it is the common condition and the common view and the common fate, and that the bright full sky we trusted as the normal state of things is the rare and passing exception. The fear was never supposed to be of the void as an oddity. The fear, the real one, the earned one, is of the void as the standard, with us as the brief deviation from it. Put all of that together, and the thing that was supposed to be frightening, the emptiness, turns out to be the ordinary state of the universe, and the thing we never thought to question, our own full and crowded sky, turns out to be the strange exception that actually needs explaining. The fear was aimed at the wrong target the whole time. We looked at the Boötes void and saw a hole, a wound, an anomaly, something that had gone wrong in an otherwise full universe. There is nothing wrong with it. It is the universe being what the universe mostly is. The anomaly is not the dark, the anomaly is the light, and we are standing in it, and we mistook it for the rule because it is the only thing we have ever known. It changes how I look at a clear night, knowing this. The full sky overhead, the band of the galaxy, the scatter of stars, the few other galaxies you can find with patience, all of it used to read to me as simply the universe, the normal background of existence. Now it reads as the rare thing, the exception, the view from one of the few bright vantage points in an enormous dark where almost everywhere else looks out on nothing. The same sky, the same stars, but the meaning of the fullness has flipped. It is not the ordinary face of the universe. It is the special case, the lucky address, the brief bright phase, and knowing that does not make it less beautiful, but it does make it feel less permanent and less owed to us than it did. We were handed a full sky. Most things never get one. That is the frame I cannot unsee now, and it is the frame the void puts on everything once you understand what the void actually is. The honest admission, the last one, is not about a fact. It is about how to feel, and science does not get to decide that for you. Nothing I have told you tonight forces dread. You could look at the same facts and feel something closer to a clean kind of clarity, the relief of seeing a thing as it actually is, instead of as the story we told about it. The science tells you what the void is and which way the universe is going. It does not tell you what to do with that. That part is yours. But I will tell you where it leaves me, and then I will let you go. Here is what I keep coming back to. We called the Boötes void a mystery, a terrifying hole, as if something had reached into the universe and torn the galaxies out. But nothing reached in, nothing was taken. The void emptied the way most of the universe has emptied, slowly, on its own, its matter drifting out toward the bright walls over billions of years until the middle went dark, and it is still emptying, a little more every age. The void is not the strange thing here. We are. The crowded sky we were born under, the near galaxies, the band of our own overhead, all of it is the exception. A thin, bright thread strung through an emptiness that is most of everything there is. And that emptiness is not finished, and it is not far away. There is a void opening at the edge of our own neighborhood right now, and we are being pushed out of it, measured and certain, at more than 1,000,000 miles an hour. So when people call the Boötes void terrifying, I think they have the fear aimed the wrong way. It is not frightening because it is rare. It is frightening because it is ordinary. It is what most of the universe already is, and it is what the bright places are becoming, ours included, given enough time. The void is not a hole in the universe. It is the universe, with the lights gone out, seen a little early. That is not a place we are looking at. It is a place we are going. If you went all the way into the void with me, a like or a subscribe helps the next one find someone who would have wanted to come along. Sleep well.